So this year the prize honors a fundamental discovery in physics. And since neutrinos are very common in our surroundings and they are very common particles in the universe, the discovery that neutrinos are actually not massless makes a difference. It makes a difference theoretically, but it also makes the difference to how our sun functions. If it wouldn't be for neutrinos, the sun would not be shining anymore. If it wouldn't be for neutrinos, supernovas would not be exploding the way they explode. The elements that we are all made of would not exist. So neutrinos are very important, but this is fundamental physics.
What are neutrinos then?
No, I wish we knew what neutrinos are. Neutrinos are among these few fundamental particles which make up matter. And we know them from radioactive decays. But what they really are, no one knows. No one has ever seen a neutrino. Neutrinos have no electric charge, and we can only detect particles which carry electric charge. And so we can only discover neutrinos when they interact with something and produce charged particles. And this is how we know there are three kinds of neutrinos, but no one has ever seen the neutrino itself.
And the prize is actually for a discovery of neutrinos oscillations, that neutrinos change identities also.
Yes.
What does it mean?
Well, it means that neutrinos, it's very hard to say that a neutrino changes identity, because it makes you think of the fact that, you have a neutrino sitting on the table in front of you, and all of a sudden it becomes something else. So neutrinos do not change identity like that. They change identity while they move through space. When they do that, you can produce one kind of neutrino, but then if you try to detect it hundreds of kilometers further away, you discover that what you catch is not the same kind of neutrino, but a different kind of neutrino. So something has happened on the way from the source to the detector, and this is what we call neutrino oscillations. And this has to do with quantum mechanics. And quantum mechanics, I can see that, as soon as you say quantum mechanics, people get totally, this is not for me, I don't want, I'm not going to understand it. But in reality, it's not that difficult. Quantum mechanics describes particles moving through space like waves. So if you think of waves in a pond, like someone throwing two stones in a pond, both stones will create waves, and these waves will interfere. And likewise in space, neutrinos moving in space are described by waves. These waves interfere, they overlap, and this is what we discover in the form of oscillations. So it's an interpretation of a quantum mechanical phenomenon.